In the previous lesson, we looked at the enthalpy of fusion and vaporization. Now we're going to look at some examples of how we use that information to calculate the amount of energy consumed or released during a phase change. The enthalpy of vaporization of methane is 8.18 kilojoules per mole. How much energy is required to vaporize 2.5 moles of methane? Like many other dimensional analysis problems, we want to look at the information that we are given, which includes two values, one of which is the enthalpy of vaporization and the other is the amount of substance. Look at these two values to determine which one is the simple unit. This tells us that we are going to start our setup with 2.5 moles. Because moles is in the numerator, in the next step we need moles to be in the denominator, so it will cancel out, which means 8.18 kilojoules will be in the numerator. As a result, moles will cancel, and now we're going to be left with units of kilojoules and the numerical value of 20.5 kilojoules. These problems are solved just like any other dimensional analysis problem. Look for the simple unit to start with and see what relationships we are given or know in order to get to the units we want for our answer. Remember, this is a vaporization, which means energy is being consumed by the system, so it's an endothermic process, and that tells us that the energy change for this process will be a positive value. How much energy is required to melt 25 grams of ice? The enthalpy of fusion of water is 6.01 kilojoules per mole. We're given 25 grams of ice and the enthalpy of fusion of 6.01 kilojoules per mole. We notice that we're given grams of ice, but that the enthalpy of fusion is in terms of moles. That means we're going to have to convert between grams and moles. In order to do that, we need the molar mass of water, which is 18.02 grams per mole. This is also a relationship, so we're not going to start our setup with that. We're going to start with 25.0 grams because that's our simple unit. Grams will go on the bottom and moles on top. Next, we can cancel out units of grams. So at this point we have units of moles, but we want to get to energy. So we need moles on the bottom and our 6.01 kilojoules on top. Moles will cancel out, and we're going to be left with 8.34 kilojoules of energy. We are melting the ice. This is also known as fusion. Therefore, energy is being consumed, so it's an endothermic process. And we'll see that the energy change for the system is a positive value.